Welcome back, friends and lovers of flight simulation. In the previous episode of the MSFS 2024 Realism series, we investigated the engines of the Airbus A330-300 and tried to start the engines with the engine covers still attached. In case you missed this episode, at the top right corner right now you have the chance to watch the episode. In today's episode we will try to take off, but we will pretend that we missed something on the walk around. Can you already guess what it is? Let's get started. So here we are doing the walk around. Everything seems to be fine. The tires look good. The brakes look good. Let's check the back of the airplane. Yeah, this looks good too. Now to the right wing. Yeah, this seems to be fine. Alright, let's take a look at the engines. No cracks. Engine fan blades are also fine. Yeah, I guess that's it. Let's get back to the aircraft. Okay, so we are back inside the cockpit. Let's take a look. 68 nautical miles from Cologne 13 left to Cologne 13 left again, ILS 13 left. This is the performance data. We have a lot of fuel. We have 20,000 kilos, 20 tons, more than enough. There's one thing to do, and this is the weather. For some reason, the weather is completely wrong. This is the weather from yesterday. Take a look at this weather. We have January 8th, 2025 and real time and live weather. But for some reason, this EFB is showing the weather from yesterday. This is why I have connected to Beyond ATC, and let's just listen to the ATIS.
QNH 1005.
QNH 1005. Cologne Bonn ground, Lufthansa 420 with information Zulu at stand Delta 18. Aircraft is A330 requesting IFR to Cologne again.
Lufthansa 420 heavy. Cologne Bonn delivery. Information Zulu core west. Expect runway 13 left. Squawk 1000.
Information Zulu is current. Squawk 1000. Departing runway 13 left. This accent is just hilarious. Turn on the APU. And the APU generator is coming to life. Now to the fuel pumps. Cologne Bonn ground. Lufthansa 420 heavy, ready for push and start.
Face southeast.
Pushback approved, facing southeast. Lufthansa 420 heavy, thank you. I don't know why he is turning right away. I think this is a bug in the sim. And now let's turn on the engines. Engine number 1 is starting. And now to engine number 2. Now this is something I really don't like about this airplane. You can barely hear the engine start sound from inside the cabin. Cologne Bonn ground, Lufthansa 420 heavy requesting taxi to runway 13 left.
Runway 13 left, taxi via Mike, Alpha 7.
Taxi via Mike, Alpha 7.
Contact Cologne Bonn Tower 124.908.
124.908. Lufthansa 420 heavy requesting departure, runway 13 left.
Cologne Bonn Tower, wind 155 at 5, runway 13 left, cleared for takeoff.
Cleared for takeoff, Lufthansa 420 heavy. This is an amazing accent, to be honest. Now here comes the fun part. I guess you have already guessed what we have missed on the walk around. We actually missed to remove the covers of the pitot tubes and the static ports. What do you think will happen? So in order to understand what will happen next, let's take a look at what static ports and pitot tubes actually are, what they are here for, and why they are so crucial for a safe flight. Unfortunately, in the past, real-world accidents like Bergen Air Flight 301 and Air France Flight 447 remind us of how critical these systems and sensors are. Blocked or malfunctioning pitot-static systems can lead to unreliable airspeed indications, which are a major risk during a flight. So understanding their function isn't just for pilots, it's essential for all aviation enthusiasts. Let's start with the basics. So static ports, these things are small openings on the aircraft's fuselage that measure static air pressure, essentially the atmospheric pressure at the aircraft's altitude. This data is critical for determining altitude and the vertical speed. Pitot tubes, on the other hand, are located near the nose of the aircraft. These things measure dynamic air pressure caused by the motion of the aircraft through the air. This information is combined with static pressure data to calculate the airspeed. On this particular aircraft we have 3 pitot tubes, 1 for the captain, 1 for the first officer, and 1 backup. And we have also 6 static ports, 3 on each side of the fuselage. This redundancy ensures that even if 1 or 2 sensors fail, the aircraft still receives accurate data. But what happens if all are blocked? That's where things get interesting. So the static ports and pitot tubes, they feed their data into the air data modules, or ADMs, which process it and send it to the flight computers. From there, the pilots see the information on their displays, on their primary flight display, including airspeed, altitude, and the vertical speed. If these sensors are blocked, like by ice or covers, the ADM's calculations are compromised. That's when we see issues like unreliable airspeed warnings in the cockpit. There are memory items for unreliable airspeed. I'm not gonna go through that, but I can recommend you this video from this channel. And of course, it is much more complex than that, but again, for the sake of this video, we will keep things simple. Now, let's ask the question, what happens if we do not remove the covers of the pitot tubes and static ports in the new Microsoft Flight Simulator 2024? So, like before, here we are, runway 13 left, we are ready to depart. Let's just do that and see what happens. As you can see, our ground speed increases on the navigation display, but our airspeed is still at 0. Let's see what happens with the altitude and the vertical speed indicator, and we have a lot of crosswind. Let's take off. So I just took off with a ground speed of around 160 knots. Let's put the gear up. So we now have a ground speed of over 200 knots. And as you can see, the airplane is already shaking. I don't know why this happens, to be honest, in the sim, but somehow this happens. I don't know why. And by the way, even if you have the auto thrust turned on, as you can see right here, it is turned on, you will accelerate and accelerate and accelerate. Let me just actually put the flaps up. By the way, we have an altitude and we have a vertical speed indicator, which makes me wonder, to be honest, why this even happens. Okay, so let me just slowly level off. If I try now to turn on the autopilot, well, you might have guessed it, it is not working. Let's turn off the auto thrust and handle it manually. So we will have to fly the airplane manually, and I'm gonna just try to slow down. So I'm gonna do a turn and we will try to actually land without any speed indications. At least we have the altitude and vertical speed indicator functioning, which I think should not be the case in real life. Like I said before, static ports usually are used to show us the altitude and the vertical speed, but those things are covered too. So I'm wondering why this is even possible. In the end, it's a simulator, it's not real life. Okay, we need to watch our speed. We are really slow right now. Oh, nice rainbow. Oh, we have a double rainbow. This is nice. Speed brakes are still out. Oh yeah, of course. My bad. So I don't like this shaking of the airplane. I don't know why this really happens. I mean, look at it. Just look at it, how it is shaking. I don't think that this is correct. Let me activate the landing system. Oh, this is one thing I need to check, to be honest, also. I guess... yeah, the red nav is not entered. Yeah. India, Kilo, Echo, Sierra. Perfect. Now we can finally see something. I don't know why it's not showing the distance. It's an ILS DME. Normally you would see the distance. I think this is broken. I can tell you right away, this is a really stressful situation. If you're doing the flying manually, checking the frequency, checking the charts, everything. We can press the approach button, and I forgot, of course, one important thing. Let's put in 300 as a minimum and accelerate again. It's actually turned to the left now. We should be on the localizer, like right now. Yes, that's it. Perfect. Look at the crosswind. We have 40 knots of direct crosswind. Okay, the wind suddenly changed. Our descent rate is actually fine. The only problem is the localizer. But we're visual with the runway, so I guess this is now not that big of a problem. Let's just try to land safely. I mean, we have a really low landing weight. I guess our approach speed should be something like 130, maybe. Okay, now for the final moment. Yeah, that wasn't bad, to be honest. That wasn't bad at all. Even the crabbing did work. So the landing went well, I guess. What do you think? I'm gonna just stop right here on the runway. Yeah, so we successfully landed the airplane without a speed indication, which was not that quite well, but it wasn't bad either. So now to summarize, as you saw, if we have the pitot tube and static covers on, we don't have any indicated airspeed on our primary flight display. I think we shouldn't have altitude indication, nor should we have the vertical speed indication. And I don't know why this exactly worked. So now comes the question, how realistic is this all? Well, I guess in terms of indicated airspeed, this is well made, and I guess this is real close to reality. In terms of altitude and vertical speed indicators, I don't think that this would be the case in real life. If you guys know better than me, please write that down in the comments. This will conclude today's episode. I hope you enjoyed it and learned something new about dynamic and static pressure systems. Thank you very much for watching. I hope to see you in the next episode. Make sure to like and subscribe, activate the bell to always be up to date. Thanks again, and like always, until next time.